Dear viewers, in this session I am going to take up a very important application using GIS for planning of educational facilities in a rural area. Well, this particular study which has been carried out is in fact has been given a national mission name called PURA, that is providing urban facilities in rural areas, a scheme to make the rural areas more attractive than the cities. The originator of this particular scheme is our Honorable past President Dr. APJ Kalam, and as per his vision, the aims of PURA is to make rural areas as attractive to investors as cities are. Then rural areas too will generate urban style employment to halt, if not reverse, the rural urban migration. This particular slide shows the overall concept of PURA which is there, where a group of villages would be connected by a ring road to convert this into a virtual town with a potential to grow, with all amenities being shared by these group of villages. For this, a rural model has been envisaged. This model envisaged that a habitat designed to improve the quality of life in rural places and to make special suggestions to improve urban congestion too. As against a conventional city, rectangular in shape, measuring 10 kilometers by 10 kilometers, the model considers a annual ring shaped town integrated to minimum of 8 to 10 villages of the same area and a excess distance of 1 kilometer to the transportation arteries. This would necessitate only one transportation route and half that needed for a rectangular shaped city. This will have zero number of functions and thus will require only a single level layout. It needs only one route as against the rectangular plan. So, the people will no longer need to change from one line to another to move from one point to another, and this saves transportation time. As all transport is concentrated to single route, high efficiency mass transportation systems become economical even for comparatively small population. This cuts costs substantially and is more convenient for general public. This model will have 4 types of connectivity, that is physical connectivity, electronic connectivity, economic connectivity and knowledge connectivity. The objectives of PURA can be enumerated as linking a loop of villages by a ring road about 30 kilometers in circumference with frequent bus services. This will integrate the population of all connected villages into one market, and then those villages become virtual cities for the potential to expand and accommodate 3 to 5 lakhs of population. Another aspect is compensating the farmers for the land acquired from them, not by a lump sum, but by an annual fee equal to twice the price of the produce they grow. This gives farmers a perpetual inflation protected income. Subleasing the land to the employers both for business and for employees' residences within walking distance of each other. This will virtually eliminate daily commuting to work and avoiding evils of city living. So, let us look at the connectivities of PURA. There are 4 connectivities: physical, electronic, economic and knowledge. The physical connectivity, as a matter of fact, takes into consideration the rail and the road connectivity, so that it allows the people to move their goods, transport cost reduction, so that it improves access to schools and health and care centers, availability of goods, tourism and public infrastructure. Economic connectivity tries to focus on the employment opportunities, value system, economic strength, women empowerment, small scale industries, urban decongestion, improved quality of life, increased purchasing power. Then knowledge connectivity, value addition, modern agricultural methods, cooperative product marketing, crop planning management, wasteland management, effective water management, proactive health care. Electronic connectivity tries to take into care tele-education, telemedicine, literacy for all, improved productivity, public call offices, computer literacy, e-commerce, e-governance and public utility services. A thorough study of the Pura mission has been undertaken by Professor P.V. Indresan, one of the very lead techno-economist scientists, who has given certain basic requirements. He states that the unit of development should be a rural development block with about 100 to 150,000 population. The provisions that Pura should have is 1,000 English knowing computer literate teachers, 4 50-bed maternity and child care hospitals, 4 cold storages and food preservation centers, 30 to 60 kilometers of ring road connecting a ring of villages and also linked to a nearby city, about 5,000 telephones, 15,000 kilowatts of electrical consumption and a modern industry in the strategic sector to provide employment to 500 to 1,000 people. Such an infrastructure would cost about 300 to 400 crores in the 10th plan, which is a fraction what it cost to maintain our metropolitan cities. Thus, the investment is not large and will address to an equally large population. Another aspect which has been taken into consideration in Pura is the recycling of natural resources. Since we all know that fossil fuel based power generation will probably get reduced drastically in the near future. So, there is a need to look for alternate energy sources. In order to provide for the same, a concept of rainwater harvesting and domestic recycling waste is necessary, so that first of all we do not need to transport long distances the wastes and the water to the areas of interest. In order to carry out a development in a region, first of all it is important that the populace in that region should be educated. So, in this particular study we are now going to focus our attention on GIS based education facility planning, and this particular approach will help us to identify how we can go for generation of information, so that certain utilities can be generated by the administrators, and for this we would like to highlight the role of GIS in developing a planning model. Nearly it has been found that about 774 million adults worldwide are illiterate. That is, they do not possess basic literacy skills, and out of this 35% of such people live in India, as per a UNESCO report published in 2008. Further, only 66% of the school of the relevant age groups at primary school level, about 42% children attend upper or middle primary school, while only 1/4 of the child population attends secondary schools, and only 15% of the children are enrolled at higher secondary level. A study which has been carried out by NSSO in 1998. Well, the reason behind this could be attributed to the serious inadequacies in educational infrastructure. So, in this particular study, our objectives are going to be assessment of disparities in the educational development, assessment of village development and identification of nodal centers, assessment of norms for educational facilities and development of fuzzy AHP based location allocation model for new planning of new educational facilities. First of all, let us look at the educational structure in India. In India, up to the age of 6, the education infrastructure is categorized as pre-primary, then primary school, upper primary school, secondary school, senior secondary school, and then it is the undergraduate courses and the postgraduate courses leading to MPhil, and then finally, the topmost educational qualification is the PhD. So, the study area for which this study has been carried out is the Luxor block, which is located in Hardwar district in the state of Uttarakhand and is located having a latitude of 29 degrees 38 minutes 27.64 minutes seconds north to 29 degrees 51 minutes 8.12 seconds north, longitude 77 57 21 east to 78 12 18.58 east. The methodology consists of data collection, database design and organization, socioeconomic disparities, age specific population projections, education disparities and gap analysis, approach for reducing the gap in education sphere, assessment of village development, nodal centers for village development, normative analysis and requirement assessment and opening up of a school. For this, the following methodology has been adopted. First is data collection. Data is acquired using satellite data, Survey of India topo sheet maps, census data of 2001, school survey data of 2002 and field survey data of 2005. So, this particular slide shows the different types of data which has been used, that is the spatial data consisting of satellite data and the topographic data, and non-spatial data, that is the village primary census abstract, details of village amenities, data on education facilities and field data on different socio-economic parameters and their various sources which have been taken for the collection of data. Once this data has been collected, two separate databases, one spatial and the other is non-spatial databases have been created. So, when we look at the spatial databases, so first of all we extract the administrative boundaries, road, railway, drainage, settlement points from the Survey of India map at 1:50,000. Also extract the block boundaries and village boundaries from revenue map and co-registered both these information onto a standard reference coordinate system. Using these reference maps, then we carry out the generation of the database. One is going to be with the help of the satellite data and the other is going to be from topographical and other theme based maps. So, for the satellite data, we go first of all we reference this satellite data to the base map and derive the land cover, land use information and send this information into the spatial database. Alternately, from other data sources, we do the geo-referencing of the revenue map and with the help of this digitization of road network, railway network, settlement points, drainage and water bodies within this particular region defined by the revenue map is carried out. After this, the topological creation is carried out for all the vector layers and any error or editing, this is carried out followed by updation and finally, the vector data information is sent into the spatial database. Based on the raster generation, we can now find out the village development index in the form of polygon, child population index, density map and percentage schedule caste maps which are there. Combine these with the road network map and the existing village and school map, we do the rasterization and classify the information into 5 classes for subsequent analysis. Similarly, the non-spatial database is carried out on the basis of the data which is available from the census data and also which is available from field survey we identify what are the physical connectivity, educational facility, economic facility, health facility, occupation, communication facility, drinking water facility, household amenities, demographic data, so that we create the non-spatial database. Then the integration is carried out, and then the spatial representation of the non-spatial and data and analysis of socio-economic disparities is carried out. The assessment of these disparities are carried out in terms of population density, percentage literacy, sex ratio, percentage of SC/ST, participation ratio. Thereafter, age specific population projections are carried out, so that we can identify the group of children going at various levels. This has to be carried out because the census data only provides number of children between the age group of 0 to 18 and does not provide us any further categorization of the primary going school or middle school going children or the high school going children. So, this has to be downscaled from the state level population to the village level population, and for this certain assumptions have been carried out, and that is that each district's annual growth rate for population at any year is set equal to the state level growth rate within which each district resides, and the same is true for block and villages. This method is mathematically equivalent to keeping the fractional share of each district population relative to the state population and constant at the base value. So, on the basis of this, the computations are carried out using these particular relationships, wherein we take the population growth of the state in two time frames, year 1 and year 2, and based on this we compute the block population for different years which are there. The third is the age specific population projection, and this has been carried out using this particular approach. So, having done the age specific projection, now we go on to the educational disparity and measurement of the assessment of the school system. This will be based on the accessibility, the quality of school, interconnectivity, utility, quantity, equity and availability of the schools which is there, so that we can identify the gaps in the education sector. So, when we look at these, so these are the parameters as just said, accessibility, availability and all these would be taken into consideration, and based on this we have certain criteria, that is the percentage of population served by a school within walking distance, percentage of villages having facility of a school. This defines the accessibility. Then availability of school per 1000 children in the corresponding group age. Then what is the quantity, that is the percentage literacy, gross enrollment ratio and share of girls in enrollment. Further, quality tries to take into consideration the percentage of schools with permanent buildings and pupil to teacher ratio. Equity takes into consideration the gender parity index, and interconnectivity takes into account the enrollment pyramids. So, based on this, and we now go on to make an assessment of the village development. The village development is carried out for not on the basis of single variable, but what we try to do is we try to work out the village development index, and for this a weighted sum approach has been adopted, which takes into consideration the population density, literacy, education facility index, medical facility index, drinking water facility index, physical connectivity index, communication facility index, banking facility index. And in this, what we now do is, based on the type of information which is there, certain weightages are provided to each of the facility located in different villages, and based on this we try to find out what is the village development index. However, this has a certain amount of biasness, as equal weightage may not be the right solution. So, we need to determine the weights. The weights can be done with the help of the ranking of the observation, that is taking the division of the observations by the mean or standard values, deviations or any other suitable value. standardizing the variable or by taking the logarithmic of the observations. After this, in order to have a very structured approach, a multi-criteria analysis approach analysis has been performed, which we call it as the analytical hierarchical approach or AHP, and the second is method of principal component. These have been undertaken for the analysis procedure, wherein we try to find out through the principal component analysis what is the weightage factor that should be assigned to each variable that have been taken into consideration. On the basis of this, we identify the parameters for village development indices, weights are given through principal component, and finally, we try to identify what is the nodal center. For this, we use the highest value of VDI and try to take into account the proximity tools, that is point and buffer distances, so as to work out what is the connectivity between the nodal centers which is there, and based on this we then proceed ahead to find out what is the connectivity assessment of the nodal centers which are there. Having done this, we go on to a normative analysis, so that we can identify what is the gaps which are there. For this, we need to identify what are the various criteria related to different levels of schooling which is there, and what type of age population should actually be considered for the GIS based analysis. After this, we make an assessment of the school's capacity, and based on this we try to find out what is the new, what would be the rule for opening a new school. These could be vector based or these could be raster based. In vector based, we use discrete point solution techniques. In GIS raster based, we use continuous space solution techniques. In the present study, a raster based approach has been proposed for selecting the site for a new school, and output of the raster output has been updated to input the vector based model to get a optimal solution. The vector based model tries to take into account the locations of the new sites to be determined using the location allocation model. The location allocation model which has been taken is P median model which is there, and based on this the formulation has been carried out. The scope of this particular allocation is to find out the location of a fixed number of P facilities, so as to minimize the weighted average distance of the system. So, based on this, certain heuristic approaches have been adopted, like Turt's and Bart's heuristics, GRAI, that is global regional interchange algorithm, and then the raster based models have been identified, developed, so that they can take into account the educational siting methodology. The criteria for site suitability of a school is based on the physical topography and social aspects, providing certain constraints, that is, the school should not be very close to a river or it should not be very close to a railway track. Based on this, certain priority ranking and preference of criteria have been proposed for different types of parameters, such as child population, village index, development index, percentage SC/ST population, LULC, distance from road, distance from existing facility, distance from village node, slope of the area. Having done this, then we go on to the allocation of, we try to find out what is the spatial location for, with the help of the location allocation model, and go for the facility projection, that is, all facility cannot be provided within one time frame. So, there needs to be some scheme by which sequential development of infrastructure has to be carried out. So, using this methodology, now let us look at the results that we have. So, now we have the socio-economic disparities which can be displayed in terms of the spatial distribution of population density, and what we can see is that population by and large is not very dense in this particular area. Light blue areas are those areas depicting uninhabited villages. Similarly, what we find is that the the percentage literacy is of the order of about 61%, while the female literacy is of the order of about 46%, and the percentage of scheduled caste population is about 24%. The sex ratio in this particular area is 872. The participation ratio, that is the working type of people, this is of the order of 31%, 31.5%, which is a very low value. Main workers in this area are only 24.5%. Marginal workers are, that is people those who work on as hired labor on fields, this is about 7%, and based on this certain growth projections of the state have been used, and on this the population projections have been carried out at per the state level, and for different years the projections have been carried out. Using this, the educational disparities have been worked out, and what we can see that each how the middle school is serving the population and which are the villages which are being served by the middle school which is there. Then the availability of primary school and middle school and high school is depicted in this particular slide. What we find is that vast areas, the availability of up to medium level schools is okay, high level schools are only restricted to certain regions. Same thing is for middle level schools which are there, only one block has a high availability of middle schools, others are having low. The availability of high schools is also low in this particular region. Based on this, certain assessments have to be carried out, and that is what is the attainment of universal literacy, that is how long will it take for the area to attain 100% literacy, and it has been found out that this probably as per the government methods would about could be achieved by the year 2023. However, certain mathematical models give different values, that is if we use a polynomial order of 3, this indicates that we would be able to achieve total literacy by the year 2011. However, a moderate polynomial of the second order says that this could be achieved by the year 2019. So, based on this, subsequent more analysis on gross enrollment ratios have been carried out, and what we can and the table below shows us the enrollment and the gross enrollment ratio which are there, and these would be taken subsequently ahead. In order to identify what is the quantity, that is sufficiency of the information which is there, buffer analysis have been carried out, and what we can see is on the basis of this the analysis of the number of high schools and intermediate colleges in terms of the availability have been worked out, and what we find is that there is a total inadequacy in terms of the availability of higher education which is there. Further, the girls share in enrollment and in comparison to boys, and pupil to teacher enrollment is not also very good. Majority of these schools have about a pupil to teacher ratio which is about 50%, while the gender parity index shows how the enrollment at different levels have been incorporated at different locations, and what we find is that this is very poor. So, now based on this we can work out the gender parity index and the enrollment parameters which are there, and what we find is that as we go up and up, the enrollment at beyond high school level is probably very low in this particular region. In order to make the assessment of village development, certain indices have been worked out, that is the educational facility indexes, and this is normally a very low information which is there. Comparison between the year census year 91 and 92 also has been shown, and what we find is that there has been very little improvement in comparison to the past census year. Similarly, the medical facility indexes, communication facility index, banking facility index, physical connectivity indexes, drinking water facility index, power supply index, household amenity index, village development index have been computed. Having done this, we also need to see what is the interrelationship between each of these indices that have been computed. So, we work out the correlation matrix of these parameters for on the basis of the field survey, which was carried out for the year 2005 and 6, and using these a certain normalization have been carried out, and thus for the year 2005 and 6 we can see the village development index which is there. However, we find that there are only 2 villages with very high development, most of them have a low development index which is there. Having done this, now we need to find out what is the nodal center for village development in each of the blocks which are there, and so based on this the Nyaya Panchayats which are there, and based on this work out where could be the nodal centers for which the schools should be, for which the development should take place. In order to take into account, we also look into the physical connectivity, the requirement of roads, and also upgradation of unmetalled roads to metalled roads based on the priority of the VDI scores. Having done this, the normative analysis is performed for the different levels of education, taking into account the enrollment and the number of schools existing at different time frames. So, on the basis of this, we need to also work out what are the norms for schools capacity, and this we find it to be that there should be a scope for expansion if there is up to 25% of the enrollment which is there, and so in this manner the number of assessments have been carried out. In this, we go in for vector GIS based LA models to find out where should our demand areas be located, for working out where should the high schools and intermediate colleges are there, and using the child population norms which are there, we proceed ahead to find out whether we need more than one facilities. Out of this, what we find is that using the child population, we can identify that at present there are 10 which are there, and we need 14 more to be made available for a child population of 422, and different child population factors have been worked out, and what we find out for a optimal value of 507, we require about 26 schools, of which 10 are present, and that is 16 schools in the region have to be developed. All right. So, based on this, we work out what is the demand and the candidate locations for the different years. We select some of the locations for the year 2006 and work out the allocated villages for the selected locations for the year 2006 for the school. We then go on to the next is we implement the raster based models, so that we can take into account the benefit and the cost aspects which are there. Certain decision rules also need to be worked out, because we have to take into consideration the optimization of such in terms of the cost and the benefits which are there, and this has to be linked to the child population. So, based on the child population criterias and their suitability, and also taking into account the constraints which could be there in terms of, that is, the road or the proximity to the river, then we work out the information which needs to be required for the same. In order to do this, we need to do some raster classification, base classification on the village development index, the child population, the land use land cover, and the schedule caste information, road layers, high school layers, village node layers, and slope layers. On the basis of this, we can now get what is the suitability index which is there, and again reclassify this suitability index using different techniques. On the basis of this, what we find is that out of the 8 sites which have been selected, 5 are suitable at this particular point of time using the raster and the vector based models which is there. So, what we find is that up to the year 2006, we require about 5 schools, up to another by 2011 another additional 5 schools have to be built up, and by 2016 only 1 school needs to be brought up in this particular area. So, based on this, what we can now say that we are able to identify the location of the schools on the basis of the results which are available, and that 11 schools are required up to 2006, and it is proposed that 5 villages may be selected for providing the new schools. Similarly, another 5 villages may be selected in the year 2011 for providing new schools, and only 1 in 2016. Thereafter, till 2026, no intermediate college is required. Similarly, another 5 villages may be selected in the year 2011 for providing new schools, and 1 more in the year 2016, and thereafter till 2026 no intermediate colleges is required. So, what we can see is that we are able to cater to population norms at the national level for secondary school in line with the Sarva Shiksha Abhiyan, which proposes that the norm of 3000, that is the total population of village, may be adopted if the target of universal secondary education is to be achieved by 2020. Vector based GIS, vector GIS based location allocation model and raster GIS based suitability analysis methods have been widely used for finding suitable locations and sites. However, both the approaches have their certain limitations. Hence, it gives a good combination. It is a combination of both gives good results. In the next session, I would take up an application of extracting building attributes from a satellite data and inputting them in a GIS environment for identifying the hazards in the buildings. Thank you.